welcome. We're ready to start our second presentation by an early career scientist today, and someone who's going to be volunteering at the Pavilion through the rest of this week. This is now Dr. Benjamin Keisling, who successfully defended his thesis, 3 weeks ago? October 15th. Oh, 6 weeks ago, yeah. And he's going to be talking about the stability of the ice sheets, and has, again, just completed his doctorate at University of Massachusetts Amherst, and will be moving on to a postdoc at Columbia University shortly. Benjamin.
Awesome. Thanks very much, Pam. I hope that completing my PhD a whole 6 weeks ago does not put me outside of the realm of early career scientists, but we'll make an exception anyway. Like Pam mentioned, I'm going to be talking today a little bit about my work on understanding ice sheet stability. If this piques your interest, then we have a whole day about ice sheets happening on Wednesday, where I'll be giving some more in-depth research presentations about what we know about ice sheets. For the time being, and let me just say, this little video that you've been watching the last couple of minutes as it's been going on, this is the kind of work that we do. This is a simulation of the Greenland ice sheet, how it responded to climate change in the past. And so I'll talk to you a little bit about how we make these kind of animations and predictions and what they can tell us about the future. So in the next couple of minutes, I'll tell you about who I am, why I think it matters that we study the response of ice sheets to past changes, where the kind of numerical modeling work that I do has taken me in the world, and then tell you a little bit about my research about how modeling ice sheet behavior in response to past climate can inform our predictions about the future. So my name is Benjamin Keisling. I'm originally from Portland, Oregon. I did a bachelor's degree in physics and both my master's degrees and PhD in geosciences at the University of Massachusetts in Amherst. In addition to being a scientist, I tweet a lot. I'll be tweeting all COP long, so you're welcome to follow along with my tweets. I've done field work on both of the big remaining ice sheets at the East Grip Deep Ice Core site in northeast Greenland, and also as part of an international expedition to the Ross Sea in Antarctica. I do a fair amount of outreach. These are some pictures of my students that I sailed with from San Diego, California, up to Alaska this summer on an expedition that's part of the STEM Seas program. It's called Student Experiences Aboard Ships. It's an NSF-funded program that gets undergraduates involved in going out on scientific cruises to see what it's like to be a scientist and how we collect data. And so if you know of any undergraduates in the United States, or you are an undergraduate in the United States who's interested in those kind of opportunities, I would really recommend that you look up that program. And then lastly, I do a lot of advocacy for accessibility, diversity, inclusion, and equity in the geosciences. I think especially as we face problems like climate change that really affect everyone, we need to make sure that everyone also has a seat at the table when we're determining our future actions with respect to both mitigating and adapting to future climate. So if you saw Heidi's presentation earlier, that was actually a really nice introduction to the kind of work that I do. I work on ice sheets, which are made of ice at just a scale that's one step bigger than glaciers. And seen from outer space, this is the Greenland ice sheet, the big ice sheet in the northern hemisphere. If all of Greenland melted, it would raise global sea level by about 7.4 meters. When we look at it like this, it looks like a big, flat, white thing, maybe not too much going on. But thanks to satellites, we've learned pretty rapidly in the last couple of decades that the ice sheets are really dynamic. And those glaciers that were flowing and surging, like Heidi showed in Svalbard, those actually exist embedded in the ice sheet in the form of these outlet glaciers, which deliver ice from the central parts of the ice sheet, which are shown here in the red colors, through what are called ice streams and glaciers, where the ice is more fast flowing, shown by the blues and the deep purples, and also indicated by the arrows. And these ice streams deliver ice from the inland part of the ice sheet, where there's usually no melting throughout the year, to its oceanic margins where the ice can be rapidly evacuated and moved away. And this kind of flow is actually really important to keeping an ice sheet in steady state, so it's not contributing anything to sea level, because there's excess ice in the middle of the ice sheet and there's ice only being taken away at the margin. So in steady state, these sort of ice streams would exist, and it's a sort of natural part of the ice sheet. But we know that the ice sheets today are not in steady state, and this really stands out when we look at the case of Greenland. So again, we have Greenland on the left-hand side here, but now we're looking at what we've been able to tell from satellites in terms of how Greenland is losing mass over the last couple of decades. You can see there's a small seasonal cycle. During the wintertime, more snow accumulates. During the summertime, more snow melts. But there's also a pretty remarkable trend. And every year now, on average, over this last 15-year period that's being shown in the animation, Greenland's lost about 281 gigatons of ice per year. That's enough to raise global sea level by about 0.8 millimeters, which sounds like a really small number, but after just a decade, that gives you almost a whole centimeter, and that's something that people can actually go down to the coast and measure, a centimeter of change in just a decade. We are also able to see from space that these changes are not happening sort of the same everywhere. There's a really strong spatial characteristic to how the ice sheet is responding, and a lot of the work that I do is trying to understand and identify how that spatial variability of ice loss has changed through time and what that tells us about what the ice sheet is responding to. So unfortunately, although we have these really compelling observations of the ice sheets from the satellite record, it's a relatively short record, and it's hard for us to know whether or not these responses are transient, or whether these transient meaning temporary or some sort of noise, or whether these changes will be maintained for a long time. And one of the best ways, I believe, we can get a sense for how the ice sheets respond in an equilibrium sense, so what is their slow integrated response to warming, is actually by looking to the past, to the geologic record. And this is a figure from Andrea Dutton and others that was published in 2015, where they looked at 4 different time periods, the present day, and then 3 time periods in the geologic past, where we have pretty good estimates of how temperature and carbon dioxide in the atmosphere changed, and also how sea level changed. And so we assume that these sea level changes are mostly due to changes in the ice sheets on Greenland and Antarctica, because for the amount of warming that we reconstruct, the actual other processes that determine sea level, like thermal expansion, they would be relatively small. So let's walk through this a little bit. On the far left-hand side, we have the present day. We refer to present day sea level as 0. That's kind of the baseline that we use for discussing how high the sea is. In the pre-industrial time, I touched something, excuse me, hold on. Coming right back to you. In the pre-industrial time, CO2 in the atmosphere was about 280 parts per million, which you will see on the screen in just a matter of seconds as we troubleshoot and try to get that figure back up. So in the pre-industrial era, CO2, oh, there it is, it's back. Perfect. Thank you so much, Heidi. Was about 280 parts per million. You see that they're labeled 1890, and we've increased CO2 in the atmosphere to today more than 400 parts per million, as is indicated on that graph. If you go to the most recent period in Earth's history, when the climate was naturally warmer, CO2 was about 280 parts per million. We actually know that from trapped atmosphere in the ice cores, but Earth's orbit was slightly different, and that resulted in a global temperature change of, on average, about 1 degree warmer than present. We refer to that time period as the Eemian. And studies of sea level during the Eemian tell us that sea level was between 6 and 9 meters higher than it was today, in response to just that 1 degree change in global temperature. The next most recent time is MIS 11, 400,000 years ago. CO2 similarly was about 400 parts per million, but in MIS 11, which was a longer time period of warmth, again due to changes in Earth's orbit, we had a slightly warmer climate, 1 to 2 degrees. I keep doing this. And sea level was between 6 and 13 meters relative to present day. How did you fix it? Did you just... Sorry, I have to learn to keep my hands just to myself. I keep knocking it. And finally, I'll just summarize. You'll see it. Sorry, wait. Yeah, it's that cord is just kind of loose. Yeah. Yeah, this is great. This is exactly what this was intended to do. We're now going to try unplugging and replugging. In the meantime, the last period I'm going to tell you about is called the Pliocene, which was 3 million years ago, when CO2 levels were actually similar to what we have today, around 400 parts per million. And there, because it's so much longer in the past, there's a lot more uncertainty in terms of what the sea level was, but we know it was at least 6 meters and might have been up to something like 20 meters. So let's go back to that slide so you can see quickly what I'm talking about, and then I will not touch anything else until we get through the end of the presentation, hopefully. And so during the Pliocene, sea level was much higher. And so basically what this tells us is that under climatic perturbations that are similar to either what we already have or what we're projected to have in the future, there was a really big response from the ice sheets. However, differentiating where that response came from, whether it was from Greenland or Antarctica, that remains very controversial and an area of active research. In the very last part of this talk, I'm going to tell you about some of the methods we use to try to figure out for these periods whether ice loss came from Greenland or Antarctica. For those of you that don't think a lot about ice sheets, just wanted to give a brief introduction to sort of how these work and how they differ from glaciers. An ice sheet is characterized by having a large area, like I told you before, where snow throughout the course of a year is accumulating more than it's melting, and an area where there's more melt than accumulation. The zone where those two things meet, where there's an equal amount of accumulation and melting or ablation throughout the course of a year, is the equilibrium line. In Greenland and Antarctica, you can also have interactions directly between the ice and the ocean. This can come directly in the form of calving, which is shown on the left-hand side, or in the case where you have large floating ice shelves, there can be both calving and melting of that floating ice shelf caused by changes in the ocean temperature. This means that there's really some major parts of this system where changes can happen that cause a change in the ice sheet. You can have climate change, which affects the equilibrium line. You can have changes in the ocean, which through ice-ocean interactions are going to result in a change in the amount of mass that you're able to lose or gain at that margin. And then there's also solid earth feedback. So the ice sheets are so heavy, they actually depress the ground underneath them. And as ice sheets melt, the ground then begins to respond. And so we have to think about all of these processes and relationships when we're using numerical models to try to test for when in the past there may have been changes in the ice sheets and what drove that. I'm going to tell you about just two things that are pretty central to my research and that I've been involved in using for my research. The first is an ice core. I don't know how many of you have heard of ice cores before, but this is where we get a lot of information about how Earth's climate has changed in the past. And these are essentially tubes that we've drilled into the thickest parts of the ice sheets in many cases. In the upper parts of an ice core, there are actually layers. So you can go back in time and read, just like you read the rings of a tree, the years as they have gone by in the ice sheet. The second thing I'm going to talk about is cosmogenic isotopes, a kind of geochemical measurement that we make from either the margin of an ice sheet or from underneath the ice sheet that help us really understand its history in a way that can help us predict its future. I want to tell you about ice cores just because even as someone that works primarily on computers, because I collaborate with a lot of scientists that are producing these data, I got the chance to participate in a field expedition to northeast Greenland where they're currently drilling an ice core. They hope to reach the bed next summer. And the way that happens is we fly to Kangerlussuaq, which is in West Greenland, and then take a US military plane up on top of the ice sheet. It was 2 years ago, so this also shows you how much someone's hair can grow in 2 years. This is me with the LC-130, that flight that brought us up there. The thing about an ice core is it's a very fragile kind of climate archive, right? You never want it to get above freezing. And even though you're on the surface of an ice sheet, even the diurnal cycle, which is funny to think about a diurnal cycle when the sun is actually up all of the time, but there are changes in the angle that the sun is hitting the surface. And so it can sometimes get warm on the surface, and you don't want that for the ice sheet, for the ice core. So before we can even drill the ice core, we build tunnels in the surface of the ice so that we can be multiple meters below the surface and maintain a drilling environment that's about -10, -15 C. In that way, we ensure that the records that we are recovering from deep inside the ice sheet aren't experiencing a lot of changes once they come up to the atmosphere. So here's what it looked like when camp was just being built. We used these big snow blowers to get snow out of the way, and then we would fill them with these inflatable balloons, put snow back over the balloons, and after a few days, it would have recrystallized into a structure that can actually maintain itself. So these snow tunnels have now stayed in the ice. The camp was established 3 or 4 summers ago. So they're pretty resilient just using this method. It's pretty cool. When you're down in the ice sheet and you're actually drilling, it's completely dark except for the lights that you have. So when you look back up, you have to be careful to make sure you put your sunglasses on. It can be quite shocking. And it's also so cold that any sort of humidity immediately tries to condense somewhere. And so that's what I would always look like coming out of the ice core drilling tent. I mentioned the other type of measurement that we use, cosmogenic isotopes. I'm going to tell you really quickly what those are and then show you some of my research that's using them. So cosmogenic isotopes are an important tracer to help us understand past ice sheet behavior. The way that this works is that the Earth is constantly being bombarded by cosmic rays, basically particles from outer space, that attenuate really quickly when they reach any kind of cover. But when they bombard a surface, they can cause changes in the chemical structure of certain minerals. And those minerals we can measure in rocks. And so why is that important? What does that tell us? Well, when you have a glacier, the rock is covered up by ice, and so none of these cosmic rays can actually reach the bedrock. But when a glacier retreats, you expose bedrock to the sky, and as that bedrock is exposed, you're able to accumulate these cosmogenic isotopes. And so we can use these measurements as a kind of clock that tell us when the glacier was last over a certain area. On the right-hand side, here showing that dark blue arrow on the far right, would have the most cosmogenic isotopes because the glacier retreated from there first before from those other sites. And so how do we use that? Well, if you go to Greenland, there are about 900 measurements now from around the Greenland margin of cosmogenic isotope measurements that tell us when the ice was last covering all around the margin of Greenland. And what that does is it gives us a target for numerical modeling simulations, in this case of the last 20,000 years. So Greenland used to be bigger during the last glacial period, the last ice age, and in response to the changing climate, Greenland shrunk all over. But there's sort of outstanding questions about whether the atmosphere or the ocean or glacial dynamics were kind of responsible for those changes. And by comparing this library of data measurements from all around Greenland with a number of different simulations, we can ask the question, did the video play before? No, I can't see. Okay, well, you can just see really briefly. You've seen this video because this is what we were looking at just on the first slide. But basically, we do a lot of simulations using different experimental design to look at the differences in what we think the atmosphere did versus what the ocean did versus small changes in ice dynamics, and then ask which of our simulations, which of our experiments can best match reality in terms of when the ice last retreated from its former position. So we do these big compilations. This is just showing the kind of graphs that I produce when I'm trying to analyze my output. We look at the difference between what do the data say in terms of the time that a region deglaciated, and then what do all of our different simulations say about the time that a region deglaciated. And we use that to identify the simulations that can actually match the data, and it tells us some interesting things. Here, and you'll hear more about this if you come to Ice Sheet Day and we really start to dig into the science. I've done a bunch of different simulations on the left-hand side that are shown in different colors, and by matching those to the data, we were able to show that during the last time when the Greenland ice sheet lost a lot of mass, the processes that were responsible for driving that mass loss, whether they were mostly driven by the ocean or the atmosphere, differ as a function of space. So we see that in North Greenland and in Southwest Greenland, the atmosphere was really responsible for driving that change, whereas in the other sectors, oceanic processes were more responsible. And that gives us a way for improving predictions about what are the processes that we should be looking out for in terms of causing major changes in these different sectors of the Greenland ice sheet. The last thing, I don't know how I'm doing on time, but I'm going to keep going. Awesome. So we have these cosmogenic nuclide measurements from around the margin that tell us about this one last time that the ice sheet deglaciated. But there's been some really surprising results recently that are fundamentally questioning our assumptions about the stability of ice sheets in response to perturbations on the order of 1 to 2 degrees. And those observations are from cosmogenic nuclides in bedrock, but they're actually from the bottom of an ice core that was drilled. So the ice is about 3 kilometers thick. And sort of just because they were drilling a hole anyway, they decided to collect some rocks at an ice core that was drilled back in the 1980s. Those rocks have been sitting on a shelf for a long time because people thought maybe we'll have something to do with them someday. We don't really know. A few years ago, some colleagues went and measured the cosmogenic nuclides in these rocks, and they found the concentrations were really high relative to what we thought the history of the ice sheet was. Unfortunately, these kind of measurements can't tell us exactly when the ice sheet went away. They only tell us that we have to have melted away the ice sheet for relatively long periods of time in the recent past. In that paper, they provided some really basic estimates about sort of end member scenarios for ice sheet stability that would equally match their data. One sort of end member, so in these bars of blue and red, the red is indicating the ice sheet would be completely gone, and the blue is indicating the ice sheet would be completely stable. And the period of time that we're looking at is the last 2.5 million years. Along the bottom is a sort of record that indicates what global climate has looked like, with the lower values, which are at the top. Those are indicating interglacial stages, sort of warm climates like the one we're in today. And the bigger values along the bottom, those are indicating glacial stages, so periods when Earth was covered by a lot more ice. And their analysis of this record showed that you could have either had about 400,000 years of ice-free conditions, followed by persistent glaciation, or you could have had a little bit of exposure every single time Greenland got warm, but every single time the climate got warm. But what's really important about this is, remember, these observations are from the very central part of the ice sheet. So in order to get cosmogenic nuclides to accumulate at the site, the ice sheet has to be basically gone. And you can see that along the bottom with those model simulations. And so what we've been doing is, instead of sort of using a global climate record to try to come up with different ideas about end member scenarios, we've been using more local climate records like ice core records and other kinds of sediment proxy records to develop testable hypotheses about when these collapses could have occurred. So these are 2 simulations showing, again, we use different assumptions about what the atmospheric temperatures were, but in this case, I'm showing in the background colors that indicate what is the accumulation of these cosmogenic nuclides. How many of these cosmogenic nuclides would we have in the bedrock for different exposure scenarios? And what's powerful about this and what's important is that these are really complex systems. When the ice is exposed, you have accumulation of these cosmogenic nuclides, but they're radioactive. So when the ice comes back and covers it up, you have the slow decay of these as well. And then lastly, when you're dealing with these big fluctuations in the ice sheet, you have to think about erosion. So the movement of the ice is actually stripping away those first meters of bedrock. And by using numerical ice sheet models, we're able to actually incorporate all of those different processes and then come up with testable hypotheses for 2 different scenarios, what we would expect the inventory, the concentration of cosmogenic isotopes beneath the ice sheet to look like today. So in this case, we're providing 2 different simulations with which both are able to match the observation that we have from central Greenland, but look very different for all of the other places around Greenland. And the idea with this is we're now able to develop hypotheses that by analyzing additional regions for what the cosmogenic isotopes are, we can really constrain when the ice sheet would have gone away in the past. The nice thing, finally, too, is that there's not just one cosmogenic isotope. We have multiple of these that accumulate in at different rates. And so by comparing them, we can come up with additional parameters that we can actually measure. Here, the ratio between two different isotopes. And you can see for these two simulations, we get different maps of how we expect that ratio to vary. And so for my postdoc and the work I'm working on now, we're going to new areas to measure these different parameters that can tell us where contributions from Greenland came in the past and exactly when that happened, so we can get a better sense of what was driving these sea level high stands that we know from the geologic record. And with that, thank you very much. I'll make the plug again that Wednesday, December 5th is Ice Sheet Day, when you can learn a lot more about ice sheets and their role in the climate system, and I'm happy to take any questions. Thank you for your patience with my removing of the thing. Yes, question. Wait for the microphone, please.
Oh, cool. Hi, my name's Fiona Turner. I'm doing a PhD on modelling the Antarctic ice sheets during the LGM. So
Awesome.
actually, a lot of the methods you're doing were quite familiar.
Awesome.
So statistics is my background. So I was wondering what sort of uncertainty you're inserting into your model and how exactly you're modelling it.
Yeah, great question. So one of the main methods that we use for uncertainty is by doing an ensemble approach to our ice sheet modeling. And so we identify uncertain parameters. And a lot of my work, the uncertain parameters is the history, the climatological and oceanographic history that we apply to the ice sheet, sort of the assumptions that we make about how seasonality has changed, and uncertain parameters within the ice sheet modeling framework, like the positive degree day method that we use for calculating surface mass balance. And so we'll look at what are the values that we think are reasonable for each of these uncertain parameters, do an ensemble-based approach, so run many different model scenarios, and then evaluate them against these geochemical data sets. And so we sort of look for which of our ensemble members are meeting the greatest proportion of the geochemical data that we have that's sort of independent.
Other questions?
Any other questions? Thank you very much.
And another plug, Benjamin's actually going to be doing two, because we only have him for 1 week here, and one is going to be focusing on the Greenland and Antarctic ice sheets, so more in depth of what he spoke about today, and a second side event about the West Antarctic ice sheet, which is the least stable ice sheet for sure. So next up, I believe, is Cecilia Morales, who's going to be speaking about her coming PhD research, starting at past. Thank you. Good afternoon, everyone. We're ready to start our next presentation of the early career scientists who are volunteering during these, in Cecilia's case, 2 weeks at the Cryosphere Pavilion. When people talk about early career scientists, that can mean anything from someone who is in their first 5 to 10 years of their career, such as Heidi, whom we heard from recently. And Cecilia is at the other end of the spectrum. She began her PhD program just this past fall. So she's going to be talking primarily about what she hopes and plans to do. So Cecilia Morales, please.
Okay, thank you, Pam. So as Pam said, I'm quite new. I just started last September in my PhD, so here I'm going to present you a little bit about the project in which I am involved and some ideas about what my thesis is going to be about. Well, I work here. This is the Instituto Andaluz de Ciencias de la Tierra, which is located in the south of Spain, in Granada. And it belongs to the Spanish National Research Council and also to the University of Granada. My PhD is funded thanks to a research project called TASDRAC, whose main objective is to study the events, both tectonic and paleoceanography, that allow the formation of the ACC, the Antarctic Circumpolar Current. And this project is the continuation of another one, which is the Drake project, which ended last year and had a related objective. Well, the ACC, the development of the ACC, the Antarctic Circumpolar Current, was possible only after the opening of the two main gateways, the Tasman one, which is that one, and the Drake passages. Those passages connected Antarctic Peninsula to Gondwana continent. And as all of you know, the ACC is currently playing a very important role in the global oceanic circulation within the conveyor belt, and therefore in the global climate system. That's why we really need to understand how this current could change with the climate warming that we are experiencing right now. Scientists, in fact, are reporting already changes in this ACC current and also in the old Southern Ocean circulation. For that, geological records can help to tell how the Southern Ocean has changed in the past, both under warmer and cooler than present-day scenarios. Yeah, okay. Here I present you the 45 million years history of the Earth. Down you have the time scale, where 45 million years is in the left, and the present day is here. We are right now at the end of the blue line, and this chart is representing the atmospheric CO2 concentration through all this time. Right now we are already below, upper the 400 ppm. And in the right part of the chart, you have represented the CO2 concentrations that the IPCC has calculated for the future. The blue line is the CO2 level that is calculated for the most optimistic scenario, and in the orange line is the most pessimistic. If we project the optimistic CO2 level to the past, to find similar amount of CO2, we have to go back between 3 and 5 million years ago. But if we project the pessimistic one, to find similar values, we have to go back almost 35 million years ago, where the Antarctic ice sheet didn't even exist. So to inform the future, we have to study the past. And that's what I'm going to do. I'm going to be focused on the Miocene-Oligocene period, where when the CO2 level were between 600 and 400 ppm, to see how the conditions were at that time. Okay, so my thesis will be focused on this area, which is the Drake passages, although my research group is working in both, in Tasman and in Drake. And we will approach this study from two main points of view. First, Tectonic, tectonic because we know that the climate has changed, but also the configuration of all the continental blocks were really different in the past. So the Drake passages is like a puzzle, and it's quite difficult to solve. So we seek to understand the patterns of the opening of the gateway. Also, the timing on the opening of the deepening of these patches still is really controversial. From the oceanic point of view, we will study sediments from the South Orkney microcontinent, which is this area there, and I will study sediments from this ODP core. And again, in focusing on the Miocene-Oligocene period, when the CO2 level were between 600 and 400 ppm. Okay, in this chart you have again the climatic history of the Earth, but this time from the 65 million years ago to the present. And in the right part you have this core, the ODP 696, which belonged to the expedition 113. By studying this sediment, we can see geological processes that were occurring at different times and correlate them with the climate signals. My colleague Adrian, who is coming next week and will explain it better, he's working in the bottom part of this core, which belongs to the late Eocene period. And he found at the very bottom you have these sandy sediments that are also present in the Antarctica continent. So they correspond to the time when this microcontinent was still attached to the Antarctica continent, around 40 million years ago. After this period, he found a very green layers that has inside a mineral called glauconite, and told about the opening, the timing, of the opening on the Powell Basin, which is the first piece of this Drake passage puzzle to open. And it's my turn to continue with the upper part of this core in the Oligocene-Miocene period and try to correlate it with the past climate observations. It's really important to keep in mind that this point, the 696, is only one point in the whole area, so it could show local signals. To extend all this observation, we have to rely on seismic data, that some are already taken and some are going to be acquired in the next oceanography campaign in June. Sorry, in January, mainly over the Powell Basin. We are also going to measure gravity and magnetic data that will allow us to study the structure of the microcontinent. And that's it. I hope to see you some of you again, so I can present you some data on some results. Thank you. Do you have any? I cannot answer. Yeah? Okay, perfect.
Just thinking about the relationship between the Antarctic continent and the Drake Passage and the proximity of the Antarctic Peninsula to the Drake Passage, I just wonder if you have thought about, or if it's part of your project, like how do you differentiate between glaciers potentially in the Antarctic Peninsula and having a whole like continental scale ice sheet?
Yeah, because this area is quite local, no? You mean?
Yeah, and maybe you could have in some warmer climates, maybe you could still have some glaciers that are reaching the coast on the peninsula, but maybe there wouldn't be a full ice sheet. Or what do you think?
We are focusing in this area, but maybe we can then correlate it with some other studies, because, for example, some colleagues are working on the Tasman Gateway, so the work is after this, try to correlate all of this.
Yeah, so I had a question about.
Yeah, it's on.
No? Now it's up. There's a glitch in it. So I was wondering a little bit if you could just say something about what types of climate proxies are you going to be working? So are you going to be is your group working with paleo models or
in this chart,
mainly proxies? Or?
All of this data were based basically on phytoplankton and foraminifers and diatoms. Yeah. Okay, that's it. Thank you.
Okay, so the next presentation will be at 4 p.m.? Okay, yeah. Okay. Thank you, everyone. We have now our final early career scientist presenting on her research, Hannah Baranes from University of Massachusetts, Amherst, and does the very interesting connection between the ice sheets, which you've heard quite a bit about today if you've been watching the other presentations, and what happens locally. Specifically, I think you're focused in the Boston region. So look forward to hearing about the latest from you.
Thank you. All right, hello, and thank you, Pam. So I'm a PhD candidate at the University of Massachusetts near Boston in the northeastern United States. I study coastal processes with a focus on coastal flood hazards. And we're standing here in the Cryosphere Pavilion. And so what I do is it's kind of one of the more tangible connections between the cryosphere and people. 1 in 10 people live within 10 meters of sea level on the coast. So processes in the Arctic and the Antarctic often affect people through coastal processes and hazards. And so one example near where I live, this photo on the left was a winter storm that hit New England in 2018, and it was the highest water level that was ever recorded at the Boston tide gauge. And I'll be telling you a little bit about why that is. A second thing I study, which I won't talk about so much today, are coastal marshes, but you can ask me if you're interested some other time. All right, so when we talk about coastal flood hazard, often coastal management practices around that flood hazard are constructed around the % chance that a given flood will occur in a year. And so I'll be calling that a flood frequency curve that relates a flood height to a probability. And so one of the most famous examples is the Delta Works in the Netherlands, which is this big network of coastal defense structures. And back in the 70s and 80s, those were designed to withstand a certain severity of flood. And so for coastal floods, they were designed to withstand the flood that would have a 0.01 to 0.05% chance of occurring in a given year. And that's the same thing that we often colloquially will say it's the 2,000 to 10,000 year flood. Another example, closer to home for me, is the United States National Flood Insurance Program. So FEMA, our emergency management organization, creates these maps, and everywhere that's covered in blue has a 1% chance of flooding in a given year. And that blue line has huge financial implications for people. So if you live in the blue area, you're required to purchase federal flood insurance, which can often be quite expensive. And if you're developing, you have to build to more flood-resilient building codes. Another more recent example is just in 2019, the World Bank gave $400 million to upgrade Bangladesh's embankment system, and it's being designed at different heights in different parts of the country to withstand certain probabilities of flood risk. All right, so how do we determine something like what's the flood that has a 1% chance of occurring in a given year or a 0.01% chance of occurring? And again, this is an example from Boston, Massachusetts in the northeastern United States. There is a tide gauge sitting in Boston Harbor that's been recording water level for about 100 years. And so the most simple way to do it would be to say, all right, we've been measuring for 100 years. And so the highest flood we've ever seen in 100 years, that's the 100-year flood. It has a 1% chance, or 1 divided by 100, % chance of occurring in a given year. And so the graph at the bottom is showing, on the vertical axis is showing flood height, and on the horizontal axis is showing basically the % chance that height flood has in a given year. And so the dots are the observations, and then we fit this line to those observations using some kind of a statistical model. And the reason that's important is, as you saw for some of these coastal defense projects, we're trying to estimate things like the flood that occurs on average one every 500 years or once every 1,000 years. And so we have to have some way to extrapolate out beyond the time period where we've been making observations. And sometimes we do it with statistical fits to data or observations, and sometimes we do it with models. Okay, so this is a problem in the world we live in today. So as you saw on the previous slide, there was one curve that gave a relationship between risk and coastal water level. And so this is from the special report on oceans and cryosphere put out by the IPCC recently called the SROC. And it says, as a consequence of sea level rise, events which are currently rare, for example, with an average return period of 100 years, that's the same as a 1% chance in a given year, will occur annually or more frequently at most available locations for RCP 8.5 by the end of the century. So as you can see, that point on the graph where we had a flood height related to a 1% chance in a given year, that might shift to having a much higher probability of occurring in a given year at the end of the century. So these coastal flood probabilities are a moving target. And so most often we think of them being a moving target because of sea level rise. But in reality, a single measurement of water level at a location, there's a lot more that goes into it than just sea level. So these numbers are moving targets not just because of sea level rise. So when an extreme sea level occurs at the coast, it's a combination of the mean sea level, the tide. So where I live, water level goes up and down twice a day, and that's a predictable natural thing from planets moving, plus the actual rise in water level from a storm, which we call storm surge, and then waves on top of that. So my focus is actually how these changes in tides are causing that sort of single curve that estimates coastal flood risk to change year to year. So in regions with large tides are a primary influencer of flood severity. And again, here's that storm that hit Boston in 2018, and I think this is kind of a powerful example. So remember, this is the highest water level in 100 years ever recorded in Boston. So the blue curve is just showing the predicted tide. So if there were no atmospheric processes going on, this is what the water would look like. It would go up and down twice a day just because of the tides. And you can see that the high tide that day when the storm hit was quite a bit higher than the average high tide. And then the green curve is showing the water level we actually measured during the storm. And so the sort of increase in water level above the average high tide, it was as much because the tide was particularly high, which is just caused by planets, as there being a big storm hitting. So tides are extremely important in determining how severe a flood will be at a given location if you're in a region that has large tides, and Boston is one of them. So we're talking about this flood risk being a moving target. So the height of tides varies naturally year to year. And so this is just a quick little primer on tides if you're not someone who thinks about them much. So the moon is orbiting around the Earth, and there's a gravitational attraction between the Earth and the moon, the same way there's a gravitational attraction between me and the Earth that keeps me from flying into space. And so if we think about the Earth as having this skin of water around it, it's being pulled towards the moon by gravity, and then it's also being pulled away from the moon by a centrifugal force, which is what we would feel if we swung around in circles holding hands. You feel this kind of outward force. And so twice a day we get high tides as we pass through these two bulges. And so this is not something that is always constant through time. Let's see. Oop. So the path that the Earth orbits the moon on, it changes. And it rotates all the way around every 18.6 years. So again, where I live in New England, if we look at a plot of, on the x-axis is time, I'm sorry, the numbers are quite small, but it's about the last 100 years, versus don't worry so much about the M2 amplitude, think about it as just tidal height. There is huge variation, and these wiggles go up and down every 18.6 years by 10 to 20 centimeters. And so there are two things that stick out there. One is that every 18.6 years, just because of the moon's orbit of the Earth changing, we have tides going up and down. The second thing is that there's also an upward trend in tides. And this is relative to mean sea level. So this is on top of sea level rise. We have tides increasing along the northeastern U.S. coast. Okay, why is this? So there are a lot of reasons that tides vary naturally year to year. One are sort of those processes like the planetary positions changing. The other has a lot to do with human things. So on the left is a picture of what Boston looked like before humans showed up in the early 1600s, and then the light green is what Boston's coastline looks today. And you can see that tides are essentially entering a different city today than they were in the 1600s, and that causes all kinds of changes in the tides, since tides are a wave. You have new reflections, you have different amounts of friction acting on the tidal wave, so yeah, all sorts of processes can change the tides. And second is that the oceans have resonant properties the same way buildings do. And so on the right is a picture of a city east of Istanbul that was hit by a big earthquake. And you can see that there is just total destruction in most of the image, but there's a structure that is like still standing in the middle, and that looks pretty much undamaged. So all things shake when you put a force on them at a certain speed or a frequency. And depending on the shape of the object, it'll move differently. And so this particular earthquake was shaking at a speed that destroyed small buildings, but did not make a tall building move. And the same thing happens in the oceans. So if you send in the wave, you send in tides, which are a wave, depending on the shape of the ocean basin you're entering, it might amplify the tide and make a really big wave, or it might not amplify the tide at all. And so what's happening in New England is as we raise sea level, we're changing the shape of the basin such that it amplifies the tides more. That's at least sort of part of the explanation. Okay, so we've established that tides change year to, well, okay, one, tides are important to flood risk in areas with large tides. And two, like sea level, they're changing. So what I'm curious about as a researcher is first, mathematically, how do we account for that year-to-year change in coastal flood hazard that's caused by tides? And second, how does that change in hazard driven by tides compare to that driven by sea level rise, since the hazard driven by sea level rise is kind of a much more commonly discussed topic? So before I get into that, I wanted to just take a quick break I've sort of interchangeably been saying 1% annual flood risk and the 100-year flood. So those are two ways of saying the flood that has a 1% chance of occurring in a given year. And I really like that 1% language much better than saying things like the 100-year flood, which you'll see in the news all the time. And I'd like to explain why with a little bit of a math activity, if you'll bear with me. So maybe think for a moment, and what's the probability or percent chance of at least 100-year flood occurring in 100 years? You don't have to answer, just think about it. So I study this, and when I first saw it, the way the question's worded, it's almost like written to make you think that there's a 100% chance, because it's called the 100-year flood, and you're giving someone 100 years. The details of how you actually calculate something like that, to have no 100-year flood in a year, the chance is 99%. To not have it in the first year and the second year and the third year, you just multiply 99% times 99% times 90%, 99% 100 times. And you get 37%, and then if you subtract that from 1, there's actually only a 63% chance of seeing the 100-year flood in 100 years. And so I would love, I think there are a lot of people pushing to get away from that language. First, because it's a little bit misleading, and second, because it's constantly changing. So talking about annual percent chance is sort of a much more clear way to talk about it, especially in a changing world. Okay, thank you for bearing with me and doing some math. So we're using this language instead now. Okay, so back to these research questions. Really, this is something I want to make clear. We really just care about this in places where tides are big. So looking at global tide range, one thing I would really like to do in the future is kind of test this method I've come up with all over the world in places where tides are large, but you have to start somewhere. I live here, so I figured I would start close to where I live and kind of test out this method in the Gulf of Maine. In the Gulf of Maine, around Boston, the tide range is 3 meters, and the largest tides in the world are all the way up north in the Bay of Fundy, and the tide range is 16 meters. I had a video which I was a little bit nervous to keep in case it didn't work, but you can see that a 16-meter tide range just fills and empties entire sort of like water basins twice a day, which is pretty amazing. So that first question, mathematically, how do we account for year-to-year changes in coastal flood hazard? Here's a nice example of scientists using words that are way too complicated. So the method I came up with we're calling the quasi-non-stationary skew surge joint probability method. So yeah, don't worry about that name, but quasi-non-stationary, that means you're allowing some parts of your hazard analysis to change. You're not holding everything constant all the time, which sort of makes sense for the world we're living in now. So again, remember, the way we do flood hazard analysis now, there's just one curve relating flood height to annual percent risk. So what I've done, now instead of just having one curve, we can predict tides. I can tell you what the tides are going to be in 2021, 2022, 2023, because I know how the planets are moving. And so what I've done, I've turned this curve sideways, and instead of just having one curve that represents Boston, you can make a curve for every year and use that known information we have of what the tides are going to be. So you might get something that looks like this, where instead of just having one curve, you have one curve for every year where you're interested about flood risk. And don't worry so much about these curves, but where it gets kind of interesting is if I take a slice, a horizontal slice through those curves, where those black lines are at the 1% annual probability, instead of just having one value, like we saw on those FEMA flood risk maps that determines who has to shell out a lot of money for flood insurance, instead, if I use this to go backwards instead of to go forwards, as you march through time, what the 100-year flood elevation is changes. So you're going from one line to many different possibilities that we can predict. And that's the quasi-non-stationary piece. And so looking at these numbers, I think sometimes it's sort of hard to say, like, okay, well, what does variation of 15 centimeters even mean when you think about tides forcing changes in flood risk? I think the easiest way to sort of visualize the significance of this is to compare it to sea level rise. So using the SROC again, that IPCC report on oceans and the cryosphere, here's what sea level rise looks like. So from 1901 to 2015, global mean average sea level rise went from 1.4 millimeters per year to 3.6 millimeters per year. And then depending on which emissions pathway we follow, sea level rise in 2100 could either be 2 to 6 millimeters a year or 10 to 20 millimeters a year. And I want to acknowledge that rates of sea level rise, these are global mean averages. So these might be very different in Boston, but I currently don't have specific local sea level rise projections for Boston. So let's compare that now, actually going backwards, to the rate of change forced by tides. So how fast are those curves going up and down every 18.6 years compared to these rates of sea level rise? And they look like this. So the rate of change of the 1% annual flood risk forced by predictable changes in tides, nothing to do with sea level rise. In Eastport, it ranges from about negative 13 to positive 13 millimeters per year. Remember, it's a wiggle going up and down and up and down. So sometimes the change rate is 0, sometimes it's negative, sometimes it's positive. So it's kind of anywhere within that range. And then in Boston, it's somewhere between like -6 and +6. So right now, it's having as big of an impact as sea level rises on changing flood hazard. And it's larger impact. And depending on what emissions pathway we follow, this sort of forcing might be outpaced by sea level rise, or tides might continue to be the dominant forcing mechanism in these kinds of regions. So the big takeaways here are that tides change year to year from natural and human causes. In regions with big tides, this variability changes flood hazard year to year. So in the Gulf of Maine, this 18.6-year tidal cycle currently causes greater variation in flood hazard than sea level rise does. And depending on what emissions pathway we follow, this may change at the end of the century. And I think another sort of way to frame this that shows the importance of it, this is that same piece from the SROC saying that at the end of the century, the 1% annual chance flood might become the annual flood. So this transition from the 1% annual chance flood to the annual flood once we consider interannual variation in that flood risk forced by tides, this change might come a lot sooner than we expect. So it's something that we need to be accounting for. And that's all I have. Thank you for listening. Does anyone have any questions?
I've been seeing that they usually mention Miami or New York disappearing with sea level rise, but I see that Boston is worst. Or how do you see this kind of marketing towards cities that will disappear because of sea level rise? And how bad is the area where you live?
Mm-hmm. Yeah, that's a great question. So one nice thing about places that have large tides is usually we've set up society to be able to tolerate big variations in water level. So Boston, I think it comes down to resilience. Boston is a lot more resilient to flooding than Miami because we already deal with the water level going up and down 3 meters twice a day. In Miami, the tide range is a lot smaller. So I think that this sort of science is really key for areas that have tides but are also not built on top of big coastal bluffs, for example. So that's kind of my next step, and I think Europe and South America are probably the next 2 places to look. Did that answer your question fully? Okay, yes. Yeah, Gustav?
Yeah, thanks. Really interesting presentation. So, so from the way you explain changes in tides to us, that would also infer that as the sea level goes up, that will change the topography of the coastline, and that will further force changes in the tide amplitude just by differences in topography. So is that something that someone is also able to model, or how well understood is that?
Yeah. So there's a really wonderful review paper that just came out kind of trying to put together all the reasons that so in reality, it's a little bit more complicated than just changing sea level rise, changing the geometry of the ocean. When you sea level rise and warming also change things like stratification, and that affects tides as well. Changing currents affects friction, internal friction, and affects tides. And so it's a good question whether there's a model now that can account for all of those processes. But if there's not already one, it's in progress. Yeah. So I guess I would say I can tell you what the tides are going to be in 2100 asterisk. We'll see.
Just clarification, because I'm later to this presentation. Mm-hmm. So you are just talking about astronomical tide, right? Because you talk about storm tide as in one of the slides. So you are not referring to storms, storm surge.
Yes, these are, so yes, this is all, everything is just forcing by changes in the astronomical tide.
And then there's the effect from the geometry and also the current stratification, things like that, all complicated factors come into play, so that there's a change in the sea level at the end, or the effect of the tide at the end. Right?
Yeah, so actually I think that all those changes you mentioned, or all those sort of impacts on tides that you mentioned, right now those are small relative to sea level rise. So that linear trend I showed you in tides in the Gulf of Maine, that's quite small relative to sea level rise, and I didn't get into that. But actually, so the biggest impacts from tides are from the planets, so that 18.6-year cycle. And in the places where those impacts become huge that you were mentioning are if you go farther upstream in estuaries. I think like on the Hudson River near New York City, or upstream of New York City, the tide range has doubled because of dredging. But out towards the open coast, you don't get quite as much, you don't see the impacts of that quite as much.
So in that case, how about do you expect any effect on the southeastern coast of China, Southeast Asia? What do you think?
I don't know, but we should talk after. I can point you to some resources, or I can get back to you. Yeah.
Could you flip back to the slide where you showed the coastline of the world and which have the highest tides?
Yes.
Thank you. So if you look at Bangladesh, which is an area with high tides, right? Because the concern is that the big loss is not the cities, it's the agricultural deltas, and there's a significant agricultural delta there. So in terms of a place to look next at importance in your studies, it might not be one of these high latitude where there's cities. It might be a delta where there is a large amount of the world's food being grown.
Thank you. Yeah, I'll take a look. Question in the back also.
Yeah, just a reminder to hold this close to your mouth because we're live streaming, and so this helps people online to hear.
Okay. Just wondering, you showed that 37% probability becomes 100-year return period.
I'm sorry, can you say that one more time?
Yeah,
I didn't quite
can
hear.
you explain the slide that you showed that the 100-year return period flood become 37%, I believe, yeah.
Sorry, the 100-year return period flood, the variation in the flood you said?
Yes,
I'm sorry, the math one, yeah, okay.
yeah. Is it
Yeah.
because of the sea level rise projection included? Yeah, this one, yes.
Okay, you're asking if this is because of sea level rise?
Yeah, I mean, I just wanted to know it more, yeah.
Yeah, so this is just sort of like almost a nitpicky thing around language. So to me, when you say the 100-year flood, to me that implies like in 100 years, that we have some expectation for a time period of 100 years. And in reality, things are changing so fast that we can't have any expectation for 100 years. And so I think talking about annual percent chances makes a lot more sense because it sort of opens up space for things to change year to year.
Okay.
Is that the question you're asking?
Yeah.
Okay.
Okay, thanks.
Yeah, you're welcome.
If I can put you on the spot.
Please, yeah.
Do you feel like the SROC was then rather conservative in terms of its projections? In terms of, I mean, essentially what we're talking about in some ways is clear day flooding, which we're already seeing in Miami right now, and the question becomes how many other places are going to be subject to that. Or at king tides, which are almost like a precursor of what you're going to be seeing then from things like storm surges.
Mm-hmm.
It's almost like that's the early warning system for coastal communities, because when that starts happening, then you can imagine in conjunction with the storm what might happen. So the question is whether planners are getting, at least from the SROC, sufficient information compared to what they might really need.
Okay, yeah, that's a good question. My sort of high-level view of it is that this is all good information about how to account for all the things that are changing in the world when you're trying to get a picture of flood hazard as a planner, for example. That's all. Methods for accounting for those things are all unfolding sort of like right now. And so do planners have access, good access to information from the SROC? In terms of accounting for future sea level, yes. In terms of accounting for things like tides or maybe changes in storm characteristics near where they live, or changes in wave climatology near where they live, no. It's just more complicated on a local scale than just considering sea level rise.
Any other questions? Okay, well, you got, as the day has gone on, I'll switch. This person got more questions, but I think a lot of these scientists will be speaking as well in the course of the week. So thank you very much. Our next event will be an evening with the Students on Ice organization. It'll begin at 5:30 local. So if you're watching on Facebook or YouTube, please feel free to tune in again then. Thanks so much.
grandmother's and my grandfather is Bob. My father is Rick, and my mom is Udlu, and those are my relations. Tonight, I'm very honored to stand in front of you guys in a full house. It's awesome to see so many faces, new and old. And we're here to talk about the Climate Action Cohort, which is something that has brought a bunch of young people together from Canada. And before I begin, I just want to make a couple of acknowledgements. His Highness, the Prince of Monaco, he's the chairman of the board for the Students on Ice Foundation. So we just want to extend the warmest gratitude for all the support for the organization. And as also Ambassador Jumo from the Seychelles is a huge supporter of our delegation in many ways. And to make the connections from polar regions from my town to small island developing states and other small island states is crucial, and that's one of the things that I really enjoy about the COP process. So just to start off, what is Students on Ice? What is Youth Climate Lab? And what is the Climate Action Cohort? So Students on Ice is an experiential education expedition. So they take 120 youth from around the world, they put them on a ship, and they teach them stuff. That's the nuts and bolts. But they teach them stuff like, what are the impacts of climate change? So we sail through the region that is actually being impacted, one of the regions that's being impacted by climate change the most, my home, the Arctic. You get to see glaciers, but you also learn things like, what does diversity mean? What does youth inclusion mean? What are these things doing? And it really helps youth come out of the expedition to learn how to be ambassadors. So that's why we have a group of 6 ambassadors as part of the Climate Action Cohort. So it's a partnership between Students on Ice and the Youth Climate Lab. So the Youth Climate Lab is a student-run, student-led organization that really focuses on offering opportunities to youth in the climate space. Opportunities through skills development, through projects, opportunities through financing, opportunities through networking. And I'm sure I'm missing a couple stuff, sorry, Dom. But those are the 2 things that bring us together. And the Climate Action Cohort, so that's the important piece here. We're going to hear from them tonight. And they are youth that are alumni of Students on Ice. The 2 organizations we're looking at, how do we make, how do we synergize, SOI, teaching about climate change, Youth Climate Lab, putting it into effect. How do these 2 things come together? So we took open call for applications. These are the lucky, there's 10 of us, but for some reasons, unfortunately not everybody was able to come. But the chosen participants participated in a nature retreat last May, where we all got together in Ottawa, Canada. We developed our skills on project development from ideation phase to reporting phase. We also did things like team building, but also things like, what's your narrative? What's your story? Why do you care about climate? We're going to hear some of those things tonight. Moving forward, we did a series of webinars leading up to COP. Seth, just want to shout you out. He put those together. They were awesome and really helped build capacity within youth before coming. And finally, this last piece is COP. One more piece. I apologize. The students were accepted on the premise that they run a climate action project in their community. What that looks like is completely up to the students, and we'll hear a bit about that in a bit. And then how does that climate project at the local level, what does that mean for COP? Like, what does that mean for this high-level policy, this high-level governance structure? So hopefully we'll kind of delve into that a bit today. I don't know if we have any volunteers on who wants to go first, but we're going to do some quick introductions. Shakti, you're closest, if that works. Yeah. Alrighty. Well, first of all, I kind of want to make this also like a dynamic space. So if you have questions, please just raise your hand, and we can try to address it as it comes, because you might lose your train of thought and whatever. I know I do. So everybody, let's give it up for Shakti.
Hi, everyone. My name is Shakti Ramkumar, and I'm from Vancouver, BC, Canada. I am so happy to be part of the Climate Action Cohort here at COP. And what I'm here to learn about is food systems and food sustainability and agriculture. I really come at this from a personal place. All of my family in India are small farmers, just like most of the world's food is produced by small farmers, yet I live in a big city that's often so disconnected from how that food is produced and what impact climate change will have on those systems. So that's kind of why I wanted to bridge what's happening in my hometown in India to what's happening in Vancouver, to here, this international space that's kind of representing all the countries in the world. So I'm really here to learn about how we can take international policy and break it down to the smallest level, from the city level to the village level, and focus on the future of food sustainability. So that is my focus here at COP. Yeah. And next up, we have Suman.
Thanks for joining us today, I guess. My name is Suman Han, and I'm from Winnipeg, Manitoba in Canada. And I attend University of Manitoba. And University of Manitoba is actually one of the knowledge hubs for the Sustainable Development Goals. So I'm partnering with the Office of Sustainability at my school, and we're hoping to create some sort of project that, I guess, talks about intersectionality, climate change, and climate action, and how those all relate to each other. So that's kind of what my project is, and I'm really excited to be here. I'm hoping to learn a lot more about environmental policy, environmental law, and how I can bring that to my home institution. Thanks. And I guess next we have Aiden.
Bonjour, miigwech. My name is Aiden Sear. I'm originally from just south of Winnipeg, Manitoba, Red River settlement there. I'm Métis from there. I currently live in Montreal, where I study public policy and political science. I was a student on ICE alumni from the year 2016, which is an experience that changed my life and connected all these little pieces of things that I've been learning in school to a greater picture. That, you know, my urgency and the reason I wanted to study policy was to gear that towards the world's most devastating crises and events, and that's conflict regions and also climate change. I did my project keeping in mind my Indigenous heritage, and also keeping in mind the mental health barriers that I see so many young people trying to overcome, especially in the northern communities. You know, we're in the Cryosphere here, and in Nunavut, the rates of suicide are much, much higher, 6 to 8 times higher than any urban center in Canada. This is something that's deeply problematic, and for our northern people who we need to be, who are and need to continue to be healthy in doing this fight for climate action, we need people's mental health to be at the forefront of that. So people are safe in person, safe in mind, in order to continue to do this work. So when I did this project, I was doing it in partnership with Grand Challenges Canada in Canada, and they have something called the Indigenous Impact Initiative, or Innovation Initiative. And what it's about is, normally when we do these frameworks of change, we consult the academics first. We don't consider the people who have the lived experience. It's the academics whose knowledge we apply, and then we realize why is there a disconnect? And sometimes that information isn't always the most accessible. So what this framework tried to do was bring community workers and youth workers to the table, but not in that sort of way that, oh, we brought youth to the table, but actually to weigh youth knowledge and lived experience knowledge at the same level. And so what we found was there actually was a lot of similarities. So that was the good news. We weighed youth voices from the north, in particular from the ICE and the mental health, and they said, you know what, our mental health is in crisis. We need, just as much as we need climate support, we need mental health support workers in our communities who right now can only come into a remote community for 2 months at a time, even less, forge a relationship and leave, which is devastating for those communities. So this framework is all about connecting people, and we were surprised what we found, that there was a lot of connections amongst academics, amongst community workers, about the sort of steps we need to do to address mental health and to address the greater problems in our world. So that's me. Thanks for letting me share. And we'll call up Will next.
Yeah, so as Rob kind of said in his intro a little bit, Students on Ice is all about bringing young people to the Antarctic and the Arctic. And I found in my expedition was the Antarctic in 2014. And after that expedition, you get so inspired, but there's a little bit of you get so excited by the moment that it's hard to translate all that learning into your everyday life. I come from a small town in rural Ontario, so a lot of times we don't feel the impacts of climate change as abruptly as they do in some of the more isolated places in the world. So my project is all about connecting international policy to those local policies and seeing where we can have climate mitigation and adaptation in the local level in rural communities across Canada. So my project is about developing new policies and mitigation strategies for local small town places so that we can kind of bridge the big discussions at COP to the local areas that a lot of Canadians and a lot of people across the world live in. Yeah, so that's my project a little bit, and I think I'll invite Mick up to talk next.
not as tall as these guys. So hello, my name is Mick. I'm originally from the Southern Labrador community of Charlottetown, which is located on the Inuit-Nunatukkavut lands. I'm currently studying law and policy at the University of New Brunswick, located in Fredericton, New Brunswick, and I have a focus on Aboriginal and environmental law. So I was in the 2015 Arctic expedition, which, as everyone else said, was amazing. It was inspiring, and it really shifted my perspective and horizons about the environmental crises that we are facing. And one of the big things about my own heritage that I really took from it is storytelling. So one of the things that my grandfather always said is passion is contagious. And for me, I always get passion and I always get inspired from other people's story. So when I got accepted to the climate action cohort, the first thing I thought about was not only highlighting my story, but highlighting the stories of everyone else around my community that have advocacy work on their everyday lives, but who don't get recognized for it. Advocacy can be a very, very hard and draining kind of job. So my project is highlighting the work of 10 other youth around Atlantic Canada and how they're impacting environmental sustainability in their own specific regions. So I talked to politicians. So we have some politicians, that member of parliament, which represents Canada. I have some people who start their own businesses, and also some people who are just living their everyday sustainably and trying to cut down on their waste consumption. So that's kind of what my project is. And again, I'm very, very thankful to be here with all these amazing folks and talking to you folks. And one thing that I hope to take from COP is being able just to bring it home to my community, as COP is pretty inaccessible for people, and trying to bridge that gap so other people can be inspired by what I learned here at COP. So next up, we'll have Marina.
Hello, everybody. My name is Marina. I am from the unceded territory of the Coast Salish peoples, also known as Vancouver, British Columbia, Canada. I'm 24 years old. I'm a member of the Climate Action Cohort of SOI, and my SOI expedition was to the Arctic in 2017, and that honestly changed my life, which sounds like a fluff phrase that people just throw around, but it's true. I'm a scientist. I have a Bachelor's of Science in Natural Resource Conservation. I'm currently pursuing my Master's of Science in Nature-Based Solutions at the University of British Columbia. And I went to the Arctic as a scientist thinking that science was the answer to the climate crisis, that all we really need to do is listen and follow the science. And I left the Arctic realizing that actually I was wrong and that people are the answer. And what we need to do is empower and lift up the people that are facing the impacts of climate the most, and who have the most to offer. When I came back to Vancouver after my Arctic expedition, with the support of Students on Ice, who has this amazing alumni program, I co-founded and now co-direct a youth-led nonprofit called Climate Guides with someone else, my friend and co-director Caroline, who is also on the expedition and who I met in the Arctic. And Climate Guides is empowering young people to engage meaningfully in climate action by providing opportunities. And we do this in a number of ways, including by setting up this mentorship program where we connect young people with mentors who are climate professionals in fields that they're interested in, facilitate that relationship, and then provide resources, including seed funding, so that those young people can develop their own climate projects with the help of their mentor and with the other mentees. So we're building a community that way. Another thing that Climate Guides does is called Youth for Nature, which is an international initiative that is empowering and mobilizing young people to lead on and act on nature-based solutions specifically to the climate crisis, with the realization that both nature and youth are underserved in the climate discussion, and they're both critical to the climate solution. So we're trying to almost address both of those gaps at the same time by lifting up and empowering young people through knowledge sharing, storytelling, and capacity building so that they can lead on nature-based solutions. And I'm kind of wearing two hats here. I'm on the Climate Action Cohort delegation, but I'm also part of the Youth for Nature delegation, which is 8 leaders from 6 countries around the world, including Kenya, Nigeria, Mexico, Brazil, the UK, and Canada, who are here, and they're leaders on nature-based solutions, and they're advocating for nature and climate here at COP on the international stage. And all of this is because of Students on Ice, and because of the support from people like the Prince of Monaco and like the folks that are here today. Young people are so grateful for people like you who come to events and listen to our voices and help uplift us and listen to us. And we need you to keep doing that so that we can work together for a future that is co-designed and for solutions that are intergenerational. So thank you so much.
Sorry, I was just talking with one of the His Highness's people there. Wow, one more time, just for the climate action cohort. So, as you can see, these are folks from all these different backgrounds, from these different places, with different intentions, different knowledge bases. But the one thing that Students on Ice does, and the one thing that I think Youth Climate Lab also does, is it brings people together to a common thread, which is why we're all here. But why the Arctic? Like, why does Students on Ice pick the Arctic? Why does Students on Ice decide to do this? Why do students decide to go on Students on Ice? There's so many questions that could help us understand this discussion and why folks are involved in what they're involved in. So just to kind of kickstart the dialogue, I have a couple questions, but if we have any pressing questions from the crowd, thank you for coming. Don't worry about it. So we'll start off with a lob. We'll start off with a lob to the climate action cohort. If you guys just want to come to the front, actually, it might be easier for you folks. And as they're doing that, there's a couple of shout outs that I also want to do. I've already shouted Seth out. He's our international projects guy at the Youth Climate Lab. He's also a new member of the board, so he's really integral to the organization. Sitting immediately behind him is Dominique, and she is one of the founders of Youth Climate Lab. Mohammed is over there as well from the Youth Climate Lab. And where is Jennifer? Okay, she's around the corner, but Jennifer is key to the logistics of making the climate action cohort happen here in COP. She's making sure we're fed, she's making sure we make it home safe, and she's also making sure that we're just, generally happy people. So this first question to you folks, you can answer one of two. Why did you decide to apply to Students on Ice? And or why did you decide to apply to the climate action cohort? Floor is open. Whoever wants to go.
So I'll answer the second one there. So the reason I decided to apply to the climate action cohort is because after my expedition to the Antarctic in 2014, I was so inspired by all the youth I met and the experiences I had and the research I was able to help on with the professors and researchers and teachers that we bring along on Students on Ice. But I felt that I wanted to take that experience and translate it into community action because although it's incredibly valuable to learn as much as you can about these issues, at the end of the day, the most value comes from taking action and trying to build communities. So the reason I applied to the climate action cohort was because I wanted to meet a group of like-minded individuals who are all passionate about turning this knowledge and this learning into action. So I don't know if any of my colleagues or friends want to speak to that a little bit more, but that's the reason I applied.
So I can kill two birds with one stone. I grew up reading this one comic book about the Arctic and the Antarctic, and that's how I got really passionate about the environment. I love spending time outside, and applying for Students on Ice 2017 Arctic expedition was actually a part of my climate action process. And after returning from the expedition, I changed all my university applications, and I decided to study environmental studies from my previous career decisions. And I just think that Students on Ice provides an excellent opportunity for you to connect with people and the environment and how those things intersect and how we need to think about it from a whole circle perspective and not just from one specific perspective. Anyone else?
Hi, everyone. I'll talk about why I applied for Students on Ice. I was 17. It was in 2013. And the reason I applied was I found that I often approached climate change from a really theoretical, books-based perspective. Before that, I read about it, I felt the outrage, I watched the documentaries, but the challenge of the expedition was something that I'd never really done before. I hadn't traveled very much. I didn't really have a visceral understanding of what climate change looked like around the world, so I wanted to challenge myself, and that's why I applied for Students on Ice Antarctic, and I was very lucky to receive a scholarship to go. And there I met some of my closest friends to this day who are also experiencing something for the first time, and I think that's an experience that I will never have again. It was just so powerful to see the effects of climate change. The parts of Antarctica where we were sailing around were the most biodiverse regions of Antarctica, and they were changing the fastest. And I think that is what inspired me to turn climate action from something I read about and watch in documentaries to something I do on a daily basis, and that it is really a daily effort. So I think that's what I learned the most from the expedition.
So I first applied for Students on Ice because I wanted to explore a different region of Canada where I have ancestry connected to that I didn't get to explore. Being from southern Labrador, we don't really have much culture from my Inuit history and background. So I really wanted to be able to explore, and I was lucky enough to get a scholarship from the government of Newfoundland and Labrador. So very, very thankful about that. And I was able to really learn more about like where my family came from and what practices Indigenous folks use to try to combat this climate emergency. And then following that, being in the Students on Ice Facebook group and seeing all the amazing work that other alumni and students have done and seeing the alumni program expand to where it is today, I really wanted to do this because of the project portion of it. I'm really tired of people talking about climate change but not doing anything about it. So I really wanted to try to do something that was practical and continue sharing the stories of other youth around Canada who are making differences and who are making major impacts.
And we're all relatively, all the cohort here, we're all relatively newer students of Students on Ice. I think the earliest one doesn't even go past like 2010 or something like that. Am I? Yeah. So you have to just keep that. I bring it up because Students on Ice it's almost 20 years old. So we're celebrating our 20th anniversary this year. The expedition is starting in St. John's, Newfoundland, Canada, and ending in my hometown of Iqaluit, also known as Frobisher Bay, and that's going up the coast of Labrador. Unfortunately, the application period has closed, but it is a really great opportunity. And why here at the Cryosphere? I think I would just give a bit of context for that. So Students on Ice goes both to the Arctic and to the Antarctic to promote and engage youth in the knowledge systems that govern both of these spaces. So one of the next questions that I want to pose to the cohort is about youth engagement. So Students on Ice, it started a fire inside of you. It's a passion. Climate Action Cohorts is one of the ways in which you've driven that forward. And now within your projects, I would just wonder if you had any advice for people on how to properly engage young people. Because, as a young person myself, I'm always hearing, oh yeah, we want the youth perspective. We want the youth perspective. And then, at the end of the day, how much does that actually come into play? How much does that voice listen to? Or in what shape is that voice being heard? So within your projects, have you thought about youth engagement? I mean, you already are engaged youth, but in your project design and development, is there anything about youth engagement that you could speak to?
Oh my gosh. Oh no. Can I just hold this? Or is that awkward? I'm worried about this. Okay. Thanks, Rob. I'm not going to touch it. Okay, thanks for the question. So how to engage youth properly or well? I think what's really important when you're thinking about youth engagement is the same It's the same thing that's important when you're thinking about engaging any group. It's reciprocity. You can't go to a group of young people and ask for their perspective and then walk away, and that's the end of the story. There are so many young people right now that are already doing incredible things for nature and for climate, despite not having the same amount of resources, attention, financial capability that some of the people that are making the decisions that are even here today do. We're still putting in the work, and often on our free time, often unpaid. So what needs to happen to really scale up that impact and to have meaningful and effective youth engagement is some kind of give and take. Like, there needs to be some kind of offer. You need to be helping us to increase our own impact. It's not coming to the young people so that you can check off that sort of youth engagement checkbox and say that you've done the work. That's not how it works. And I think a lot of youth engagement that we see even now is really symbolic and tokenistic, and often requiring unpaid labor for a group of young people who are already doing so much unpaid labor for the climate crisis. So if you're engaging youth effectively and in a way that it is addressing intergenerational justice, you're doing it in a way that is reciprocal, is you're offering an offer, and you're uplifting the work that young people are already doing instead of taking from it or competing with it. I think that's really important.
There it goes. All right.
Did I do that one?
Marina's okay, that's what matters. How about this? I think this is a better setup. Can I just leave it like this here now instead of putting it under the laptop?
Not touch it. So I think Marina pretty much hit the nail on the head. So I work for Student Energy, a nonprofit that engages young people to take action on energy, and we work a lot with the energy sector. And unfortunately, the energy sector traditionally has been one of the least transparent, least accessible sectors for young people. It's often unclear what kind of influence they can have, what kind of impact they can make in their professions, in their academic, in their studying. So that's where Student Energy tries to intervene. And what I want to add to what Marina said is it's so important to mobilize resources towards youth-led solutions. This doesn't always look like money, but does include money. It includes time. It includes access to real decision makers. I find that often young people, like Marina said, they're consulted and then their ideas and their opinions kind of go into a black box, and it's unclear what impact they've had. So what Student Energy has really done is creating spaces where young people can ask tough questions in a constructive, productive way, and be part of the follow-up process so that they know where their feedback is going and they can continue to shape how their work is used and what kind of impact they can have in the energy sector. So I think really recognizing the history of the industry that people are working in is so important, and kind of doing a critical analysis of how have we engaged youth in the past, how can we kind of expand this space to be more accessible is really important. And the final piece is that the youth engagement process itself should be co-created with youth. They know best how to engage their peers and how to reach out to different groups of the youth population that may not even know about different opportunities, so it's important to co-create that process as well.
So we've kind of talked about, who we are, why we're here, So let's shift gears a bit, guys. Let's go towards like where we're going. So this is a pretty, COP is a very intense place, especially this year with it being a COP of ambition, and we're looking to really hype that up and make sure that we are rattling our shakers and we are making sure that our voices are being heard. So as a COP with ambition, where do you guys see this fitting into your projects, and how is the knowledge you're gaining here going to help you in your projects, but also in your community, and how do those all kind of relate?
Yeah, I can speak to that for a bit. So my project in my community is about developing. So I come from a rural area, and we're reviewing our next 10-year strategic plan. So from 2020 to 2030, we're looking at how our small community is going to address our economic and environmental and socio problems, I guess. So within that space, I think it's really important that we include climate action within our community plan, even though we're a small community and even though the effects may not be felt directly in the next 10 years, those places are where the foundation of climate change is happening, and we're just as much a contributor than any other place. So making sure that those local places are just as accountable as the corporations and cities and all the other big contributors to climate change. And for me, my experience at COP hopefully is going to take away learning about how international policy works and the interplay between policy writing and developing a policy and negotiating with stakeholders, and taking some of that experience back home and being able to apply those learnings to a local setting. So hopefully that's the next step for me.
I just want to pump the brakes on my questions for a couple seconds. Do we have any questions from the audience at the moment? Caroline, do you have a question? Dom, do you have a question? Just kidding. Oh, 1 second, there's a mic coming.
Something that I'd love to explore is also the collaboration between alumni, because I know as a previous Students on ICE alumni, I've had the opportunity to collaborate with Youth Climate Lab and other amazing initiatives that have come out of it. So I would love to hear what has come, not only just the climate action cohort and how you've been collaborating among it, but if you have examples of the ways that collaboration has come out of it.
Yeah. So for myself, I'll speak to kind of my experience as an alumni a little bit. My first COP was in Paris at COP 21. I was coming for a bunch of side events, and Students on ICE said, hey, we don't have anybody going. Do you kind of want to be one of our ambassadors? So I said, yeah, sure. I didn't really understand what that meant. So that was my first foray into the kind of alumni program. And then we met a year later in Hawaii at the IUCN conference. So for me, the most tangible ways that collaboration can happen through the alumni program is through these delegations and is through these ways in which where dialogue happens. So it's, for me, I almost want to say it's always those informal connections that we make as alumni. Nobody here was on my expedition, but I still feel like they all were, because we share that commonality. So I think just getting people into the room is a great idea. And then I'm just going to bounce that back to you guys on the question. Do you need the question repeated, or are you good? Yeah, so we'll just repeat the question. How does collaboration kind of manifest itself within the alumni program, and after, doing the things that you're all doing, and, I'm just going to add to the question a little bit, if you're cool with that. Youth engagement, ambition, how does all of these things tie together?
I think for me, what I take away from that question is when you're, as a youth, existing in post-secondary education institutions or whatever home, rural, local community you're in, it's good to know that you have a support network of people who have had that experience, that have connected you to a region that you might not have otherwise known, to understand maybe your personal sense of urgency surrounding climate. I've seen this, I've been there, I've had this experience, and that storytelling really is super powerful for the people around you, But also, when we do storytelling, it can also exhaust yourself, especially if you're talking about it from a place of heart. And I think for me, in the back of my mind, knowing that Students on Ice and those students and those people from my year, that group chat is always open, and those people are always there. They're there to support you, and they have the same experiences. And I think that's part of the change that we need to see, is to build these support networks to go along with the change that we're trying to make, because empowering the people is just as important. So that'd be my answer. Once again, guys, just thanks for coming out. This has been great. I stand up there and I just am so in awe of being able to, be here with you folks. It's not often I get lost for words, but anybody have a question? Yeah, I guess I could speak to, Dom? Do we have that runner mic? Thanks, man.
Awesome, thank you. Bonjour, bonsoir. Yeah, I have a question. I think you folks are so rad, as I know you all, and you're so privileged to have had the experience to go on Students on Ice and to be here at COP and to do all the incredible things you're doing in your communities. And I wonder, what is something maybe you would tell your younger self? What's something that you've learned along the way that you would, share with your younger self or share with another young person, who are maybe earlier on in their journeys?
I'll take a quick stab if you don't mind. One thing I'd tell myself is go for it. Just go for it. Opportunities present themselves to people who are eager, people who are keen, and people who are interested in making a difference. Well, Aiden talked about how when you speak from the heart, that's most often the most draining. It's also most often the most rewarding, because people get to see how passionate you are about something. And that right there makes them want to give you an opportunity. So that openness and that eagerness, I think, are two things that have helped me. So I would tell my younger self, hey, man, I know you're shy. I know you think you can't do it, but you can get past that imposter syndrome and just give her.
Totally echo what you just said. Oh man, I feel like I still need to tell myself that. You deserve to be here. Your voice deserves to be heard. I think imposter syndrome is so real. Another thing I would tell my younger self is that there is no climate action that is sustainable without community. I think for a long time I felt like I had to do it by myself for some reason. I don't know why I had that feeling. I just felt like this was something that you have to do alone. And I think we romanticize that idea of that sort of sole activist or individual leader who is changing the world all by themselves. But the reality is that never happens. There is no one who is changing the world all by themselves, and that's impossible. If you try to make the kind of change that we need on an individual level without any kind of community support, without any kind of help, you're gonna burn yourself out quickly. And we don't have time for amazing, incredible young leaders burning themselves out because they're trying to do everything by themselves. So community is the key to a climate action that is effective and that is sustainable and that will deliver the change in the action on the scale that we need it to.
So something that I still struggle with a lot is I was always so scared of being wrong about something, and I was so scared of saying the wrong thing. Maybe I don't sound intelligent enough, I don't articulate as well, but it's really learning that, I can't be the expert of everything, and I shouldn't be the expert of everything, and that's why we rely on communities to be able to kind of fill the gaps and make sure that we're getting all sorts of perspectives, because I can't have all sorts of perspectives, right? So that's why I'm allowed to rely on my community. I'm allowed to make mistakes. I'm allowed to learn from those mistakes as well. So that's something I still tell myself every day, and I probably will for the rest of my life.
Again, continuing on this line of community and burnout, I think one thing that I would tell myself is to be kind to myself and to allow time and patience for the unproductive me, the me that can't check off every single task of my to-do list, because activism is such a tiring role to play. And to have that community to back you up and to have that community to go home at night and to shoot a message in that group chat, as Aiden said, just saying like, hey guys, like I know we had this project to do, however, I need a few more days, I can't get my part done. And perhaps they can stand up and be like, hey, I can take over a piece of your project. So just being honest with yourself, and like I said, just allowing your time for yourself when you do feel kind of low and burnt out.
I have another question, if there's time. So you've all kind of already, thank you, first of all, for sharing your work. And many of you have already engaged with this, but I wondered if you could just reflect a bit more on, you've talked not only about climate action, but other issues, mental health and community that are really facing youth today. And I wonder if you could elaborate on how you see climate activism in general and your work specifically engaging with other social movements and other sort of movements for social justice.
Yeah, that's a really great question and a really important one. I think that a lot of activists are kind of struggling with, and it's struggling with because it seems overwhelming, but like inevitable that we have to address many issues at the same time. And I think what I've been reflecting on recently is that the process is so important. There's a lot of climate action there where the end goal is the only thing that's important and we will use any means necessary to get there, but that has never worked in the past to lead to a sustainable, better world for all people, and that won't work now. So I think that's why a lot of young climate activists are saying, no, we need to focus on economic justice, on racial justice, on all aspects of social justice, and that's the only way we will get to a climate-safe future that is for everyone and not just for a few privileged folks who can kind of survive the worst of it. So in my personal focus area on agriculture and food systems, this is probably the #1 priority. Is the food system represents 1 billion people who often don't have access to the spaces where climate action is being discussed, where their futures are being discussed without them being part of the conversation. So I think my focus is really going to be from here to take all this and kind of connect the dots to grassroots movements that are already happening. They're just underfunded, under-resourced, and don't get the attention that they need. So my goal is to kind of connect the dots between the two.
I think one of the messages that we always forget is climate change is intersectional. It encompasses everything. And one of the messages I think that big corporations are trying to push is that it's up to the individual to make a change. And it shouldn't be. We need to start educating more and tell stories more about everyone's individual path within environmental sustainability. For example, plastic straws target a really small, vulnerable community of people who might have physical disabilities and they can't use metal straws. In Northern Labrador communities, the banning of plastic water bottles will leave them without clean water. So being able to share those stories and those unique perspectives and experiences of all different types of folks is something that I'm trying to do to educate kind of the general population of people who might not have to think about this because, as Shaki said, they are very privileged and they don't have to think about that. So just trying to share those unique perspectives of other people who are trying to fight the climate action way in the best way possible, but every single thing that they're doing, they feel like they're not doing it well enough because mass media is saying that they're not doing it well enough. So sharing those stories and those perspectives.
Any more questions? Alrighty, I got one last one for you guys, if that's all right. So going forward, in the next 2 weeks, how do you see yourselves fitting into the process? What forums, what working groups? I guess I just really kind of want to dig into, if the folks in the back want to start engaging these folks, what are the spaces they're already occupying, and maybe some folks in the audience can also provide opportunities at the end. Not everybody needs to come up, but if some people, like Youngo is an example, but if you guys just want to come touch on what you hope to achieve over the next 2 weeks in terms of actual tangible examples of where you'll be and what places so folks know where you'll be, that would be greatly appreciated.
So yeah, I can start. So at school right now, I'm studying mechanical engineering and business administration, and a big passion of mine is energy systems. So I'm hoping over the next couple weeks to really dive into that on a global scale, not just look at local energy, but global energy. So those are the spaces I'll probably be in for the next little bit.
So I'll probably be attending the Climate Law Symposium happening on Friday. I think it's this Friday. And hoping to connect with different think tanks and academic institutions for collaboration.
So I kind of have two main goals here at COP. One is on the energy side. Since I work for student energy, I'm really focused on how countries are involving youth in their energy nationally determined contributions that are going to be re-upped next year. Energy is the biggest source of emissions and is a core part of many countries' NDCs. So I'm really going to dig into how they're engaging youth on a global scale and how we can support our youth network to get involved in implementing those NDCs. And on the climate action cohort front, I will be trying to meet as many non-state actors and grassroots activists as I can, working on food systems and agriculture and land use. So that's an area where I'm very new to the field, so I'll be learning as much as possible. Yes. Mm-hmm.
I'm getting more and more concerned about corporations buying up water rights. I know I'm from the United States, and T. Lou Pickens has just died, but he basically got all the water rights underneath in Texas. And so corporations and really wealthy people are buying up the water rights.
Mm-hmm.
And if there's anything that we can't do without as human beings, is drinking water. And I'm really, really concerned. It's not just about potability, it's not just about toxicity, it's not just about environmental racism, it's that we're going to be having horrible times in terms of having to pay for water.
Mm-hmm. Yeah, thank you so much.
And the prices are just going to be exorbitant. I mean, I just think it's a disaster beyond everything else that we're doing. It's a disaster in the making.
Yes, definitely, and it's a human right that shouldn't be privatized, and it's happening all over the world, and that's something that's very closely intertwined with the issues that I'm interested in. Both energy and agriculture both deal with water so much, so that's now that you've raised it, I'll make sure to focus on that as well as I continue in my next 2 weeks.
Hi, yeah, I'm so afraid of this. I have very specific goals at COP25 as a part of the Youth for Nature delegation. Our mission with Youth for Nature is to ensure that youth are able to co-design their own futures with nature, under the understanding that there is no 1.5 degrees without youth, but there's also no 1.5 degrees without nature. We need both of those things if we are to meet that target. Our goals, thank you, Shakti, for bringing up that the NDCs are to be enhanced next year. So COP25 is crucial to build the ambition so that we see revised NDCs that actually meet the urgency that is required and that include nature in a way that allows nature-based solutions to reach their potential. Nature-based solutions can fill 1/3 of the mitigation gap needed to reduce emissions, or to reduce temperature rise to below 2 degrees, and even more if we were to reduce below 1.5 degrees. So I'm really focused on advocating for that and advocating for youth specifically to be included in those NDC revisions so that we can be leading on the way that nature-based solutions are featured there, and so that those nature-based solutions are grounded in science, traditional ecological knowledge, and are enshrined in justice. Those are sort of our biggest goals. I'm going to plug a couple events. We have a young politicians panel of young politicians that are already leading on nature and climate on the 4th at, remind me what time it is. It's in the morning. It's at 10. And it's in the SDG Hub. We have a youth rally for nature-based solutions in the Action Hub on December 7th at 2 p.m. We have a intergenerational dialogue for ecosystem Oh yeah, and I can talk to you after this and give you all the details if you'd like. That's Young Politicians Panel in the SDG Hub on December 4th at 10 a.m. Yes? No? You're going to tell me later. I have a youth rally for nature-based solutions on December 7th at 2 p.m. in the Action Hub. And on December 13th, it's an intergenerational dialogue for ecosystem restoration. So looking at how young people, but also elders and other generations are working together for ecosystem restoration. That's on December 13th in the Panda Hub at 10 a.m. Thank you. And we're speaking on a bunch of other panels too. So you'll probably see a couple Youth for Nature folks at a bunch of other panels throughout the 2 weeks. So I encourage you to reach out to us so that we can make sure that you are also attending those events and that we can connect. Okay, thanks.
Sweet. So just one last time, I think that's going to conclude for today. One last time, I think we should just give it up for the climate action cohorts and the support team that's here. And let's have fun these weeks. So on the schedule, Students on Ice was going to be showing 4 short pieces of film, about 2 to 3 minutes each. That was at 1900, but we're just going to roll right into that. So just bear with me as I get this USB set up. But yeah, that's what's going to be happening next. It's not formatted properly. Are they MP4s? Your USB is not formatted properly. Let me try this again. Preview? Yeah, so they're there.
No. No lo reconoce. No recognize. A ver. Other pen drive?
I'll try something out. Yeah, so we're just gonna have to take 5 minutes to try to figure this out. So just stand by. Alrighty. So, thanks for sticking around. We have 4 short films to show you right now. The first film that we're going to show you is the Climate Action Cohort film that was made based on our nature retreat. So you'll see images of us attending a climate action rally, and you'll see images of from expedition, as well as images of the nature retreat.
Climate Action Cohort is a group of 10 students on ICE alumni from across Canada who are all getting together to learn more about climate policy and to work on initiatives in our communities.
These SOI alumni will be working together for 2 years as our inaugural cohort, and we're kicking things off this week at the Spring Nature Retreat just outside of Ottawa. This awesome collaboration between Students on ICE and Youth Climate Labs is aiming to bridge the gaps between international policy, community action, and youth engagement.
I think it's really important for youth to be involved and to be engaged in climate action because we are the future. We're the future leaders of not only our communities, but of Canada.
They're proven leaders within their communities, and now we're hoping to give them the training and give them the resources to take that a step farther and produce climate action within their communities.
I think it's very important that we are involved with the climate action now because we are the future. We'll be taking over the positions in these parliament offices one day.
I know from my experience with Students on ICE so far, I've just learned so much about climate change and what's happening in the world, and I'm really excited now to learn about how to take action and be effective in the action we take in our communities.
And it's really awesome to see everyone come together with unique backgrounds and unique perspectives and share their stories and passions about climate change. I really believe that passion is contagious, so everyone being under the one roof and all these amazing stories is really lighting the fire under my own butt to come together and, get this thing happening and to get these.
Over the next 8 months, this cohort will focus on developing and executing their community projects while supporting each other as youth-to-youth mentors. We're so excited to see these projects come to life, and we can't wait to share them with you.
Yeah, I guess we should have plugged the Lawson Foundation like an hour and a half ago. Now we're going to move into the expedition recap. Nope, stop. Aviar? Yeah, which one is that? Abricot. Abricon VLC. There we go. Spanish 1010 obviously did nothing for me.
This place is so amazing and beautiful, and just getting to be one of the few people on Earth that actually get to experience this place. I'm so happy that I get to see it.
We saw this happen all the way around Greenland.
We don't have to have a trade-off between conservation and development.
Healthy youth, healthy adults and elders that engage with each other and to work with each other.
Not enough action is being taken. And so in many ways, we're taking things into our own hands.
It's a relationship with the ocean, and that's really what we need to really ensure ocean health moving forward.
Standing out, looking at the glaciers, the mountains, humbled and honored, and I'm so grateful to be here.
We all have important roles, even if we don't feel like we do.
I think it's really hard to understand the breadth of the issue without seeing it firsthand.
We as a community and as people can see life in its true beauty and just see the impacts that a community that cares can make a difference.
We all part of one big, huge thing called planet Earth.
The agreement that comes out of this is going to directly benefit the people of the region.
Be mindful of your daily routines, what you do every day, and that will help make a difference.
The greatest impact has just been to be out of my comfort zone every single day.
We are leading generations, and we will be needing future leaders that make a difference.
Experiences like Students on Ice can help us achieve our goals and help us pursue our passions.
To think that I'll be able to take what I know and bring it back to where I live or where I travel, I find that so empowering.
So as you can see, it's quite the journey. The next piece we have was, it's a poem accompanied by some visuals done. The poem is done by 2018 alumni.
They say the Arctic is a barren place. But how can it be barren when my feet never touch the ground for all the life nestling in rocks like a mother's mouthpiece? 1,000 tiny worlds on a mountain, by the sea, in a glance between two people, in the shell of a sea urchin whose story ended long ago. 1 square foot, a dozen kinds of plant, all edible, all in relationship, all life-giving. Oral history weaves the story of a life carved into the hills since time immemorial. Women laughing, knowledge keepers. Loving the land helps us to love each other. I think of the lawns back home, cold, stark, uniform, regimented. Is that the lush diversity of which we are so proud? Some people never see the trees through the forest. They say the Arctic is a remote place. But how can it be distant when the people are so close? Welcome us with open arms when we pull up to their shores, lost, disappointed, invited into a celebration, concert, soccer, dancing, breathing the same deep breath, throats singing, guts full of laughter and eventually matak. Sharing makes our culture stronger. Shake hands, good game, hug goodbye, cousins. If soccer is an international language, then we wrote a love song on the field. One last song, one last touch. This is why I don't travel, because I never know if I can come back. Can't you just stay? Can't we just stay? Leave me here, hiding in sorrel, big as the day is long, mourning the relationships we never knew we needed. For our interaction, lifelong memory, ancestral belonging, destined to meet again in this life or another. Kiss the ground, kunik the kids, lick the iceberg, thank the sun for bearing witness. They say the Arctic is a barren place.
saw some visuals of it. It's called Croker Bay, and Croker Bay is in Arctic Canada. It's a very special place for myself, and a lot of the visuals that come from this shot, I was actually standing 250, 300 meters above them, bear guarding, making sure that everybody was safe from polar bears. So I got to watch like the whole production of this come together, and it is quite a powerful film. And this is the last one of the evening. So after we'll take questions, but if not, we'll just let the film roll out, and then we'll carry on.
For every 2 breaths you take, one of them comes from the ocean.
50% of the world's oxygen comes from right here.
Right here. Right here.
2 breaths.
1 from the ocean. 1.
2.
The ocean is the base of life on our planet.
But our oceans are threatened.
They're sick.
They're dying.
And not just the ocean.
Our biodiversity, our climate, our nature, our culture, our planet, ourselves.
If you're watching this,
A person with power and the ability to change the world.
then do better.
Do better.
do better. If you're sitting in your house or office,
Shielded from the effects of climate change, then do better.
then do better. If you've turned a blind eye towards what's happening in this world,
Then open your eyes and do better. People without voices are fighting to get a voice.
so if you already have a voice,
Then do better.
I am the change.
I am the change.
I am the change.
You can be the change.
You can be the change.
Be the change.
We will all be the change.
We will all the change. We will all be the change.
2 breaths, 1 from the ocean.
And one last thing I'll say, other than thank you, once again, thanks to the tech guys. I know how hard that life is. And the last thing I want to say is just thank you to the Lawson Foundation. So the Lawson Foundation is the organization that has provided the funding for the climate action cohorts to be possible. And without them, we wouldn't be here. So just a huge shout out to them. Huge shout out to you guys for staying, and for Jen. And it's the Cryosphere Pavilion as well that hosted us here today. And I appreciate you guys so much. Sorry for forgetting about you.